Pretty creative name to this section. 1.6 is called Other Types of Equations. And the reason it's called Other Types of Equations is because we're basically getting into equations that are not like the ones that we've studied. So the ones we've studied are linear equations and quadratic equations. Linear equations, you get one solution. Quadratic equations, obviously, we're getting two. So now we're getting into other types. So let's see if we can't look at some. First way we're going to explore is to solve polynomial equations by factoring. Then radical equations, equations with rational exponents, equations that are quadratic in form, equations involving absolute value, and problems modeled by equations. So we're going to look at solving polynomial equations first by factoring. So here's our first example. What we'd love to do is we would love to be able to solve for x. But as you can see, we have multiple variables and they have different degrees. So the first thing we're going to do is go ahead and get it set equal to 0. So I'm going to move everything onto the same side. I'm going to do that by subtracting 27x squared. Now, I always like to make my problems easier, and since we're working with equations, our variables are very important to us, because right now, this polynomial has a degree of 4, so we're going to find 4 solutions. But the numbers themselves, the coefficients, they really don't matter to us. So anytime I can make my numbers smaller, I'm going to go ahead and do that. When I divide everything by 3, since that is the common factor, divide that by 3 and you get a nice little 9. When you divide by 3, what it's going to do, it just makes your numbers smaller, usually easier to work with. And like we said in the intro, we're going to solve this by factoring. So first step of factoring is always to factor out the common factor. When I do that, I'll get x squared minus 9. And then my next step is, this is a monomial, so I can't factor that anymore. And this is a binomial that has its difference of squares. So we'll factor to x plus 3, x minus 3. And then what we're going to do is we're going to set each of our factors equal to 0 and solve. So when you set x squared equal to 0, that's really x times x. So what we're going to talk about is you'll get x is equal to 0, and what we're going to say is that it has a multiplicity of 2. And the reason we say it has a multiplicity of 2 is because that 0 really occurs twice. So this x could be equal to 0, or this x could be equal to 0. And one thing that you'll start to see is that when you see that there's an exponent of 2 for your factor, that that 0 actually occurs multiple times. And then when you set this equal to 0, you'll get x is equal to negative 3. And then when you set this equal to 0, you'll get x is equal to 3. So again, the degree of our polynomial was 4, and what that should tell us is that we have one solution here, but this solution actually occurs twice. So therefore, that gives us a total of 4 zeros, which is matched by the degree of our polynomial. So again, just a little reminder, anytime you have a factor that has an exponent, that's going to determine the multiplicity of that 0.